Welcome back guys to the part 3 of NLP lecture. In the previous lecture, we wrote a function for text processing in which we were removing the punctuations and then removing the stop words. Moving forward, let me introduce another term which is tokenization. So what is tokenization? For a given character sequence and a defined document unit, tokenization is a task of chopping it up into pieces, called tokens, perhaps at the same time throwing away certain characters such as punctuations. For example, if you have an input such as friends, Romans, countrymen, lend me your ears, and semicolon, after tokenization, your output is going to be friends, Romans, countrymen, lend me your ears. You don't have punctuations anymore. These tokens are often loosely referred to as term or words, but it is sometimes important to make a type distinction. So let's do the tokenization now. Before we move on to the complete dataset, we can grab few messages from the data frame and see how the function process_text work while tokenization. Let's check only two messages from our data frame before tokenization and after tokenization, which mean before applying process_text function and after applying process_text function. So df SMS column and call head on this column only and see only two messages and run this cell. So we have these two messages at index 0 and 1. Let's do the tokenization on these two messages only. So df grab SMS column, only two messages, head 2. We can use apply and then call the function process_text. So what we are going to do, we are applying our custom function which is process_text and passing two messages to see how the output will be. So this should be apply here once again, and let's run this cell, and here we have. Notice that the stop words are removed and we got the list of tokens that are actually the words we want. So moving forward, at this point, I want to introduce another very important concept of text normalization to you guys. Let's pause this lecture and learn about the text normalization now. There are lots of ways to normalize the text data. In this example, we have used a simple text normalization in our text pre-processing. NLTK library has a good number of built-in tools and very helpful documentation on other methods of text normalization. You can check the documentation of NLTK on its official website. The key concept in NLP includes tokenization and stemming. We have already learned about tokenization, whereas stemming involves the extraction of stem words in the text normalization. For example, if we have similar words in our text, such as play, playing, and played, the only useful word is play. Stemming tries to return play only. In our dataset, stemming may not be useful because of the presence of several shorthand words such as letter U, number 2, U, C, na, and so on. This is common in text messages. So, stemming may not be very helpful in our particular dataset. However, it works greatly in several cases such as news data, book data, research articles, and so on. Another important thing is dealing with currency symbols and other type of regular expressions. You can consult the documentation of processing raw data to learn more about this. The link is provided in the Jupyter notebook. So moving forward, let's apply process text to SMS column in our data frame to get the tokens for all messages. So let's grab df sms and call apply process text, and if we run this cell, we are going to apply this custom function to all messages in SMS column in our data frame. Let's run this cell. Depending on the size of your data set, it may take some time as well. So here we have the output. If you don't want to see this output, you can simply put semicolon here. Now we have created a method to get a list of tokens. As already mentioned, in order to do machine learning using Scikit-learn, we need to convert each message into vector form. These tokens are not going to work for machine learning because machine learning understands only the numerical data. So to move on, recall the bag of words technique from the lecture notes. We will do the following steps using bag of words model now. The first thing, term frequency, by counting how many times does a word appeared in each message. The second one, inverse document frequency, which is actually a way the counts. Recall the lecture notes. Frequent tokens get lower weights. The third one is normalize the vector to unit length to abstract from the original text length. Recall from the lecture notes how the first step will look like after term frequency. You can think about it in the form of following table. Each vector have as many dimensions as there are unique words in the SMS corpus. So don't worry about all this process. Luckily, Scikit-learn have a built-in tool, Count Vectorizer, which convert a collection of text documents to a matrix of token counts. Before we move on, I am going to introduce another term here, which is sparse matrix. In numerical analysis and computer science, a sparse matrix or a sparse array is a matrix in which most of the elements are zero. Imagine how many zeros you should expect in your matrix of token counts. Lots of zeros, since there are so many messages, so many words in the bag of words, and lots of words missing in each message. You will get a sparse matrix. Anyhow, let's move on and import the count vectorizer now. From sklearn dot, it is under feature extraction dot text import count vectorizer, and let's run this cell. So count vectorizer, and if you press shift tab, you see you have a range of parameters that you can pass in. In this case, we are going to pass in analyzer, which is our process underscore text function, the function we recently created. In the output, we will get bag of words after processing the text according to the analyzer. The text data is large and process may get some time. Depends upon your computer as well. We are creating a very large matrix. All the rows are words. So BOW transformer is going to be count vectorizer and pass in analyzer equal to process text. And what we do, we call fit and pass in the data that we want to process here, which is our SMS column. Let's run this cell. As I said, it could take some time and depends on your machine. So we have bag of words here, which we called bag of word transformer. Let's see how many words we got in our vocabulary. So we can use BOW transformer and call vocabulary. And we want to see the length of these words, so let's pass into length and run this cell. So we have 11,425 words in our bag of word transformer. In bag of word transformer, each word has its own ID. Let's check the ID for any random word, say way here. We can check it using BOW transformer dot vocabulary underscore dot get, and let's pass in way here and run this cell, and here we have 10,979 is the ID for way. Let's add few cells. Moving forward, to get better understanding of the working process, it's a good idea to transform a single SMS to its BOW or bag of word count as a vector first. We need to call dot transform on both transformer or bag of word transformer and pass in the selected SMS. Let's select any random message here. Say we want to work with the 19th message here. We need to grab the 19th message using its index location at 18. So SMS 18 is going to be df SMS column and grab 18. And let's run this cell. To see what this message is, copy this one, paste it here and run this cell. So the message is fine if that, some random stuff, the way you feel that, and once again something x92s, the way it's gotta be. Let's transform SMS underscore 18 to its bag of words. So bag of words for message 18 is going to be bow underscore transformer dot, we call transform on bag of word transformer and pass in the message, and the message is SMS 18. And let's run this cell, and now we have BOW underscore 18, a bag of word for SMS underscore 18. So let's see how the bag of word 18 and its shape look like. So we can use print BOW underscore 18 and then print BOW and call shape on this one and run this cell. So here we have one row with entire vocabulary along the columns. So these are the IDs for the words and how many times they appeared in this text. Like only one word with ID 10,979 appeared twice in this text. And if you notice, 10,979 was the ID for way. So in conclusion, we have 8 unique words in the selected SMS 18 after removing stop words. And only one word, which is way, is appeared 2 times. We know it is way because we know its ID already. From the board transformer, we can call the method get underscore feature name and ask for the any word using its ID. Let's check what is 6517. So we can once again use print board transformer, call get underscore feature names and pass in the ID. Let's check for 6517 and run this cell. So 6517 is field. Let's recheck for 10,979. We already know this word is way. Just rerun this cell and we have way again. So the way words appeared twice. Now let's move on and use dot transformer with both transformer or bag of word transformer and transform the entire data frame of SMS corpus. Let's add few cells and df underscore BOW, so df underscore bag of word is going to be bow underscore transformer, and we call transform and then pass in the entire column of all the messages df SMS. So df underscore BOW or df underscore bag of word is going to be the bag of words for our entire data frame. Let's run this cell. Once again, this could take some time. It depends on your machine as well. Let's check the shape of our df underscore BOW matrix, which is a matrix of token counts. We can also check how many elements are non-zero in this matrix. df underscore BOW dot shape and run this cell. So it has 5,572 rows and 11,425, which is entire vocabulary, as columns. To check the number of non-zeros, we can call df underscore BOW and NNZ, which is non-zeros, and run this cell. So we have 50,548 non-zero elements in our df underscore bow matrix, which is again a matrix of token counts. As I already said, this is a sparse matrix. We can compute the sparsity of the matrix as well. So to compute the sparsity of this matrix, let's find out the total number of elements in this matrix. We can simply multiply number of rows to the number of columns to get the total number of elements in this matrix. So the total number of elements would be total elements df underscore BOW, call shape on it and grab 0 index, which is 5,572, and then df underscore bow dot shape and grab at index 1, which is going to be 11,425, and let's run this cell. And if we print this total element, we have 63660,100 number of elements in our matrix. So let's add few cells, and to calculate the sparsity, which is actually df underscore BOW dot NNZ to the total elements, multiply by 100. So let's run this cell and see what the sparsity of our matrix is. So here we have the sparsity of our matrix is 0.7940. We can use round function to round this up to some numbers we want. Anyhow, this is not very important at the moment. So guys, excellent job so far. We are done with the term frequency, which is how many times a word appeared in SMS. For example, we learned that the way appeared twice in the message at index 18. Now it's time to compute for term weighting and normalization using TF-IDF. Recall your understanding on TF-IDF from the lecture notes with some practical examples. I'm going to split this lecture here, and we are going to continue from the same point in our next part of the same lecture. See you in the next lecture. Good luck.